Hello students, today I am going to explain my important concept-wise questions about on Tautomerism and RS nomenclature for JEE Mains and NEET for 2020. Right. So first question, which can show Tautomerism? Tautomerism. So Tautomerism is exhibited by mainly two conditions. C double bond O group is, that means keto group. C double bond O group is called keto group. The keto group is attached to an saturated carbon and at least have one alpha hydrogen. So these two are very important conditions to bring tautomerism, which are exhibit or not. And one more thing, I have given a link in description about tautomerism and RS nomenclature because already I have completed in my previous classes. So, right. So, which can show? Let us, what are the condition here? C double bond O group is attached to an saturated carbon. Here, this is C double bond O group is, that's why this is keto group. So, this keto group is attached to this carbon and this carbon. Yes, this carbon is saturated or not? Yes, it is saturated carbon. That's why this is sp3 carbon. sp3 means carbon to carbon single bond. So the first condition is satisfied. So keto group is attached to this carbon. This carbon is already in sp3 hybridization and saturated carbon. So that's why first condition is satisfied. And what is second condition? At least have one alpha hydrogen. Yes, this carbon has two alpha hydrogen. Yes, this carbon also has two alpha hydrogen. So this carbon is alpha carbon and it is also alpha carbon. So this carbon has two alpha hydrogen. This carbon also has two alpha hydrogens. That's why this is ready to involve in tautomerism. So first option is correct. And coming into second option. What is second option here? CH3 CH2 bond NO2. And one more thing, sir, here NO2, the central atom is nitrogen. So it is based on nitrogen atom tautomerism. I have already explained in my previous classes about on tautomerism concept. So here, this is example for nitro to acinitro tautomerism. This is example for nitro to acinitro tautomerism. Nitro to acinitro tautomerism. Because this is our right now here functional groups are. So this is attached to this carbon. Yes, this carbon is saturated carbon or not? Yes, it is saturated carbon. And it is sp3 carbon. And one more thing, it is alpha carbon. Yes, here how many hydrogens are? Two hydrogens are there. So two alpha hydrogens and saturated carbon. So that's why it is also exhibit tautomerism. And coming into this one. Yes, here this is keto group, sir. Yes, keto group is attached to this carbon and also this carbon. So this carbon is not to support to involve in tautomerism because it is unsaturated carbon. I told you already, saturated carbon is the first condition. So this carbon is saturated carbon and it is sp3 carbon. And it is acts as alpha carbon. Here how many hydrogens are? 3 hydrogens. So these 3 hydrogens acts as here alpha hydrogens. Total we have 3 alpha hydrogens and it is saturated carbon. So that's why. So it is also to involve in tautomerism. So that's why 1, 2, 3 or 3 are ready to involve in tautomerism. That's why option is fourth one is correct. Next question. Which of the following compounds show higher enol content than keto? Higher enol content than keto. That means we need to find here more stable enol form than keto form. More enol form depends on some factors. What are the factors here? 1. Resonance stability, hydrogen bonding, that means chelation, and aromatic in nature, and solvent effect and steric effect. The 5 factors are to affect percentage of enol content. That means more stable enol compound. That means more stable enol form. So, but among these five predominate resonance effect, hydrogen bonding, and aromatic nature. These three are very, very important to increase enol content percentage than keto form. So let us check whether it is possible or not. Let me take first question here. Here C6H5CH4 benzaldehyde. So benzaldehyde, here aldehyde group is there. Aldehyde group means here C double bond OH, right? Here C6H5 sir, that means benzene ring here. So write down benzene ring. So this C double bond O group is attached to double bond to carbon. That means here sp2 carbon. So it is not a saturated carbon here. That's why first option. So not possible to exhibit tautomerism. That's the first option is a wrong option for this question. And next option. Here C6H5 benzene ring plus C double bond O group is attached to this carbon. Of course this carbon is saturated carbon and it is sp3 carbon and also have alpha hydrogens. So it is to involve in tautomerism. Here I want to take one hydrogen, bond break here, immediately hydrogen get positive charge, this bond rotate between these two carbon and this bond rotate towards oxygen and this proton is migrate towards oxygen. So what is the next step here? C6H5, this is keto form sir. H5 OH double bond CH bond H, carbon to carbon double bond, that's why it is ene. Here alcohol suffix ol, so this is enol form, right? Okay, second option to produce, to exhibit tautomerism, right? Next, coming to third option here. Here this is keto group. Here keto group is attached to this attached to this carbon and this carbon, but this carbon is not possible to involve tautomerism because this is unsaturated carbon. It is possible because saturated carbon here. Here how many hydrogens? Two hydrogens. So these two hydrogens are called alpha hydrogens. So I want to use one alpha hydrogen. Your bond will break here. Hydrogen get positive charge. This bond rotate between these two carbon and this bond rotate towards oxygen. Immediately this hydrogen towards migrates towards more electronegative of oxygen. So the next step here, bond, yes. Right. So this is a correct representation. So new bond appear here and it is get OH, right? Here also carbon to carbon double bond in, alcohol suffix is enol. Now it is keto form, right? So it is also to exhibit tautomerism. Next, fourth option. Here two ketones are there. It is example for diketone. Yes or no? It is example for diketone. Example. So this is alpha carbon, sir. Of course, it is also alpha carbon. But comparatively these two, this is more to produce more substituted alkene than this one. I told you already in previous class. In my previous class, end of the carbon is always less substituted alkene to be produced. But this is not end of the carbon. It is to produce more substituted alkene. That's why I can use this alpha carbon. Right? So here two hydrogens are there. I want to use one alpha hydrogen. So here bond, here break. Immediately this hydrogen get positive charge. This is to migrate towards between these two carbon. Oxygen negative charge and towards oxygen. So next step, C6H5OH double bond, that means alkene here. So C double bond O CH3, right? So carbon to carbon double bond in alcohol suffix is ol, enol form. It is keto form, right here. So among these four, first one is not to produce tautomerism, but second, third and fourth. Three are to involve in tautomerism. But which one is more stable? We need more enol content than keto. That means more stable enol form than keto form. We need to bring among 2, 3 and 4. Here look at second one here. Look at second one. Here I told you already what are the condition. One, resonance stability, hydrogen bonding and aromatic in nature. Here no conjugation. Here no conjugation and no resonance and no hydrogen bonding is there. Right? Because no electronegative atom is there. That's why here no resonance and no hydrogen bonding. That's why enol form is less stable here. Less stable enol form than keto form. Here keto form is only more stable. That's why here no enol content than keto. So that's why second option is also wrong option for this one. Now coming to the third one. Here keto forms are. In this enol form, it is 100%. It's the most stable enol form than ketone. Why? Because it is benzene rings. Conjugation is there. Double bond, single bond, double bond, single bond, double bond, single bond. That's why it should be involved in resonance. More stable. And it is moreover, it is aromatic in nature. So benzene is aromatic in nature and resonance. That's why it is 100% enol form, more stable than keto form. So it is the correct option for this question. But coming into next option. Here also sir. Here hydrogen, here more electronegative is there. That's why intramolecular hydrogen bonding is there. This effect is called chelation effect. Of course, hydrogen bonding, chelation. So stable. And what about resonance? Yes, resonance is also there, sir. Why? Because single bond, double bond, single bond, double bond. So it is 100% resonance is possible. So let me check hydrogen. This bond rotate between this here and this bond rotate here and this bond rotate here. So here immediately this one. Yes, it is resonance is possible. So resonance is there. Intramolecular hydrogen bonding is there. That's why it is more enol form is more stable than keto form here. So among these four, third and fourth are more enol content than keto. So that's why third option, fourth option is correct for this one. Third option and fourth option. So third option is correct for this second question. Next, which of the following show stable or major form of tautomerism? So we are going to find which of the following is more stable, enol form or enol content of this one. Right? So let me take the first question, first option. Here we have two ketones. This ketone surrounded with two carbons. That's why these two carbons are acts alpha carbon. So here also this ketone attached to these two carbon. These two are acts as alpha carbon. Of course, it is right to involve in tautomerism. You can take any one. So let us I want to take here this alpha carbon. This alpha carbon. Okay. Then what happens, sir? I want to remove one. I want break bond between hydrogen to carbon. Hydrogen get positive charge. Immediately this bond rotate towards here and towards negative. Oxygen get negative charge and this magnet towards oxygen. So what happened the next step? Yeah, it will get OH, double bond and keto group here. So you know what here? This enol form is less stable than keto form. So it is the first option is not show stable or major of for tautomerism. Why? Because here this is not so stable, sir. Because here hydrogen bonding is not possible. Why? Here hydrogen and oxygen far to each other. Here hydrogen and oxygen fought each other and no resonance is there. So here no resonance. Yes, here no resonance, sir, because conjugation, no conjugation is there. Double bond, single bond, double bond. Double bond, single bond, single bond. I told you already, double bond, single bond, double bond, single bond. This is called conjugation. So here no conjugation system, that's why no resonance and no hydrogen bonding is not, here hydrogen bonding is not possible because more electronegative of oxygen atom and hydrogen far to each other. That's why here no hydrogen bonding is possible. So first option is correct. First option is a not correct for this one. Next, second option. Here this carbon is alpha carbon for this keto group. This carbon alpha carbon for this keto. You can use any one. So I want to use this carbon alpha carbon of hydrogens. Here two alpha hydrogens are there, right? So here bond here break. This bond rotate towards between these two carbon and hydrogen get positive, and here rotate towards oxygen and oxygen get negative, and enone form is possible. So write down enone form here. Double bond OH keto group is there. So here enone form. It is keto form. It is keto form here. You know what? It is more stable. Enone form here more stable than keto form. Here the keto form is less stable. Why, sir? Because here resonance is possible and intramolecular hydrogen bonding is also possible. So intramolecular hydrogen bonding is possible and resonance also. Resonance. This bond rotate here, bond rotate here, and this bond rotate here. So here resonance is possible. That's why it is more stable, and hydrogen bonding is also possible. So that's why it is more stable compound than keto form. So second option is show stable or major for tautomerism. Second option B is correct. Coming into third one. What about third one, sir? It is simple ketone. Only one ketone is there. I told you already in my previous classes. Simple ketone or aldehyde. Simple ketone or aldehyde always less to form less enone content percentage. That means less stable enone form than keto. So here keto form is more stable than enone form. So third option is not correct for this question. And coming into fourth one. What about this one? Here three ketones are there. Of course, this ketone is not too sufficient to involve tautomerism, because here this carbon no alpha hydrogen, this carbon no alpha hydrogen for this keto. But this carbon is alpha carbon for this ketone. This carbon is also alpha carbon for this ketone. So that's why this ketone and this ketone to involve in tautomerism. So here two alpha hydrogens are there, right? So here bond here breaks up. Immediately this bond rotate between these two carbon. Hydrogen get positive charge, and this bond rotate towards oxygen. Oxygen get negative charge here. This is migrates towards oxygen. But the next steps are here. Next step here, right? Keto, OH, and double bond. You know what here? Watch. Double bond. Here intramolecular hydrogen bonding is possible, and also resonance also possible. Why, sir? Because here this bond rotate like this, and this bond rotate like this, and this is towards like this. So resonance is possible, and also intramolecular hydrogen bonding is also possible in D option. So it is this enone form is more stable here. Right? This enone form is more stable than keto form. So D option also to show stable or major of tautomerism. So B option and fourth option is correct for this question, B and D. So total second option is correct for this one.